In this lesson, you're going to determine how to create a line of best fit to model a trend in data. You're going to do this by looking at scatter plots. So scatter plots are created from two sets of quantitative data. So on this particular one you see, we've got weight on the x-axis and height on the y-axis. And I can see as weight is increasing, the height tends to increase as well. So there is a positive association that I'm seeing. There are three types of association. The first being positive association, that as my x increases, my y tends to increase as well. Negative association would be as my x increases, my y tends to decrease, and there's no association when the points really have no obvious pattern. We have different ways of measuring the strength of my association. Specifically, correlation measures how strong the letter R represents that. All right, what we're going to actually be doing in this video, though, is determining a best fit line to model the trend in data. So let's illustrate this with an example. Mr. Thomas wanted to know if the amount of class time that he gave students to study affected their test scores. The scatter plot below shows the results. What kind of relationship between class study time and test scores is shown in the scatter plot? So first of all, I'm seeing that as study time increases, the average test score tends to increase as well. So I see a positive association. Now, you can't necessarily say that study time is causing the average test score to increase, although, we might expect that, but there's no way to prove causation. We just notice an association. Now what we're going to do is we're going to try to create a line that seems to best fit these points. So when you sketch your line, you're going to find that some points fall above and some fall below, and you might have to kind of adjust it a little bit. Right here seems pretty good. I've got some points below, some above, and now we're going to determine the equation of this line once you think you have it in a pretty good spot. And to do this, you're going to choose 2 points that fall directly on this line. They do not need to be data points, okay? Meaning not those black points that you see, but I'm going to emphasize 2 in blue right here. So I would say that ordered pair looks to be about 10, I'm going to say 77. And I'm going to choose one other point on the line. So I'm going to go with this one right here, which looks to be about 25. I'm going to say 86. And now we're going to model this best fit line with a linear equation. It's just a line. So we're going to compute our slope by doing 86 minus 77 over 25 minus 10. Now I will mention that often when you're finding your best fit line, your numbers are not going to work out to be real pretty, all right? And this is just an estimate because the reality is the line I drew might be very different than the line you drew. All right, I need to find B, my y-intercept. So I begin with y equals mx plus b, and I'm going to plug in. I'm going to use the point 1077. It's my choice. I can use either of those two. My slope is 3/5. My x value is 10 plus b. Do the algebra, and I get b equals 71. So my best fit line would be y equals 3/5 x plus 71. And I would use this then to make predictions. So predict the average test score of a student who studies 23 minutes. I would do y equals 3/5 times 23 plus 71. And I plug this right side into my calculator and I get y equals 84.8 would be my prediction for test score. Now, like I was saying, this is just one possible best fit line. So depending on how you draw your line, your equation could be a little bit better. So of course we have some methods for making your best fit line really be the best fit line. And we're going to use technology to find this. And this is actually known as a regression line, or at least Square's regression line. And we're going to use the graphing calculator to learn how to do this. So if you haven't downloaded an app yet, please download one of the suggested graphing calculators if you're learning from home. So you're going to determine the equation of the line of best fit using the graphing calculator. So again, we could make a scatter plot, we could sketch a graph, find 2 points onto your slope and your y-intercept. But let's look at how to do that within the graphing calculator. You have to find the regression line on your calculator. So the first thing you need to do is hit Stat and Edit. You're going to enter your raw data by Stat Edit. Now, if there's already data in one of these lists, go up, highlight L1, hit Clear, Enter, and it wipes out all the numbers in the list. Then you're just going to type your numbers. In list 2, you're going to enter all of your Y values. It's important that you list your values next to each other, meaning here's your X and its corresponding Y. So from left to right, you have an ordered pair, so go ahead and list all your Y values. I've entered all my data. You probably want to just double check. I'm going to go back to the main screen by hitting second quit, or second mode, which activates quit, and then I'm going to run the regression. Okay, so that's back in stat, arrow over to select calc, and here's your linear regression option 4. I have to tell the calculator where my data is. It's in list 1. So I hit second 1 for list 1, and I'm going to change this to list 2. Now by default, it's probably already list 1 and list 2. I go down and I select calculate, and here is my regression equation. You may not see the r squared and the r on your paper. Instead, this right here is your slope. It tells you A is your slope and B is your y-intercept. So you will copy that onto your paper. So my equation is y equals negative 0.007, I'm going to take it to 3 decimal places, x plus 22.271. So the next thing I'm asked to do is to describe the relationship in the scatter plot between elevation and average temperature. Well, because my slope is negative, that's telling me that without even looking at the scatter plot that I'm going to have a downhill line, so I'm going to see a negative association. But I'm going to now show you on the graphing calculator how to do that. You might actually want to make the scatter plot and check out what that looks like. It's always kind of nice. So to do that, your graphing calculator can do it by hitting second y equals for stat plot. And I encourage you to do this with me. You're going to go in and you're going to turn your plot on. So I highlight on, scatter plot is your first option, and again you tell the calculator where your data is. So your X is in L1 and your Y's are in L2. And then the easiest way to see the graph is hit zoom 9. It will automatically adjust your scatter plot, so here you can see your data values. I'll quickly show you how to actually see your regression line or your line. So I'm describing the relationship now. There's a negative association as elevation increases. In number 5, we're asked to predict the average temperature for a city that's 750 meters above sea level. So I just substitute 750 into my best fit line, and I get y is approximately 17.021 degrees Celsius would be my prediction. Finally, 6 says La Paz is the capital of Bolivia and sits at a very high elevation, about 11,975 feet or 3,650 meters above sea level. Use the model to predict the average annual temperature, and then is this a reliable prediction? So to make my prediction, I just plug in the 3,650. And I get approximately negative 2.84 degrees Celsius. So that's very cold. But then the next question is, so how reliable is this prediction? And here's how you can kind of tell. This value of 3,650, I want to compare it to my other X values, okay? How does that compare? Well, it is much, much bigger. It's outside the interval. My smallest X value is 490, and my largest that I see is 2200. 3650 is large. So this is an example of what we call extrapolation. And with extrapolation, you don't get reliable estimates because you have no idea if the pattern is going to continue the way you presently see it. So I'm stating that this is not a reliable prediction. Our previous value that we predicted in number 5 was 750. That was within our X interval. This is known as interpolation. When it's within our interval for our domain values, we can rest assured that it's going to be a fairly decent prediction. You should now be able to algebraically find the best fit line. You should be able to use technology to find a regression line or your best fit line. You should be able to use your equation to predict. And finally, you should know the difference between interpolation and extrapolation and recognize that extrapolation does not produce very reliable predictions.